Hello, future mathematicians and future scientists. I welcome you to the channel Class of Excellence Academy. My name is Mr. KJ Malakwani, and I'm here for you, more especially if you need intervention sessions. So I'm going to be taking you through each and every mathematics and physical sciences topic, whatever topic it is that you are struggling with, however you are struggling, I am here just for you, more especially for you. If you feel like you are being left behind, you are still trying to catch up, but hey, everyone seems to be moving faster than you. Listen, this channel is specifically made for you. So what you need to do is just to make sure that you subscribe, you like and share this video so that everyone could also have an idea of, you know, getting some knowledge somewhere else. So let's get to it, right? Today I'm going to be mostly covering geometric sequence, right? I'm going to be covering geometric sequence with you. Then if I get to have some time, we'll get to series and also to quadratic sequence, as I have already covered arithmetic sequence. But let's get on to our geometric sequence just in a bit. Let's go. Right, ladies and gentlemen, under geometric sequence, we need to remember that a geometric sequence of numbers in which each new term, except for the first term, is calculated by multiplying the previous term by a value called constant ratio. So you remember that in arithmetic, we needed a constant difference. But now in geometric sequence, we need a constant ratio. So that particular number, we need to multiply it to the previous term so that we get another term. Right. So we must also remember that we can do that except for the first term. Now, let us remind ourselves, ladies and gentlemen, the general formula for geometric sequence is what? It is Tn, that is equal to what? A multiplied by r, then to the power of n minus 1. So, where a is the first term in sequence and r is the constant ratio, right? So, let's get on. To test whether a sequence is a geometric sequence or not, check if the ratio between any sequence between any two consecutive terms is constant. So, how to find the r? The r, to find it, then we must divide the term 2 over the term 1. We can also further by saying term 3 over term 2. And then we are going to do what? We are going to say now term nth term over Tn minus 1, which will give us the constant ratio, which is r. If this condition does not hold, then the sequence is not geometric sequence. Right? Let's look at the example, ladies and gentlemen. I took some example somewhere from a certain textbook. I think it's Everything Science. Yes, I took it from Everything Science. Now, let us look at this. We are saying now Tn is the number of newly infected people after n days. So here we are given this. Tn is equal to 2 multiplied by 2 to the power n minus 1. So we can write it like this, or we can write it like this. We can say Tn is equal to T into 2 then to the power of n minus 1. Either this way is still right or this way. Right. Then the question says now calculate how many newly infected people there are of the 10th day. Calculate how many newly infected people there are of the 10th day. Now, second, we have a question that goes like, on which day will 16,384 people be newly infected? Right. To tackle these two questions, let's get on to the first one. To the first one, we must know the known values. What are the known values, ladies and gentlemen? We have the first term, which is a, and that's equal to 2. We have the constant ratio, which is what? Which is 2. Now, for us to calculate this, we are going to say now Tn is equal to 2 into 2, then to the power of n minus 1. So after that, we are going to do what? We are going to say now, okay, because of they are saying 10th day, we are going to have T10. They said 10th day. So we are going to have T10. So T10 is going to be equal to 2 multiplied by 2 to the power n minus 1. I said you can either write it that way, or you can say 2 into 2 to the power of, then you'll be writing 10 minus 1. Remember that 10 is actually the n. So then 2 multiplied by 2 to the power 9, or you can write it as 2 into 2 then to the power of 9. So that will give us 2 multiplied by 512, right? 2 to the power of 9 is 512. So 2 multiplied by 512 actually gives us 1024. Gives us 1024. So it means now the 10th term will be 1024. So there will be 1024 newly infected people in the 10th day. I'll give you that particular sequence on a later stage. All right, ladies and gentlemen, so from that example, we were given a sequence like 2, 4, 8, 16, and 32. 2, 4, 8, 16, and 32. So it was a very long scenario that I don't want to take too much time going through it, because it's going to take us a lot of time. So I took this particular sequence. So I had to look at, okay, so we are given 2, 4, 8, 16, 12. So it means this 2 is our A, because A is the first term of the sequence. Then we need to find the R. Then to find the R, we need to do what? We need to take the T2 and divide it with T1. So we can also take T3 and divide it by T2. Remember, this is to check the consistency. All right, it's to check if we are having a constant ratio. You can't just work with two numbers and assume that you have a constant ratio. You need to also to take other terms to make sure that you have the same or the constant sequence. Right. So then, so R is equal to, then we are having 4 divided by 2, which is equal to 8 divided by 4. This is the T3 over T2. This is the T2 over T1. So obviously, ladies and gentlemen, we can see 4 goes how many times into, 2 goes how many times into 4? It goes twice. 4 goes how many times into 8? It goes twice. So hence we say our R is 2. So our A is 2 and our R is 2. So that is how we basically find the constant ratio, right? So this is actually the sequence that we were given, ladies and gentlemen. Let's now go to the second question. The second question says, on which day will 16,384 people be newly infected? On which day will this number of people be infected? So to look at that, here for us, we need to use the general formula to find n for 16,384. We know that we have the number of people that are infected, but we don't know after how many days. What day will that be where we are having 16,384 people with newly infection? So we are going to now take our general formula. We are going to say now Tn is equal to A multiplied by R to the power of n minus 1. So we have Tn, right? So we write it there. 16,384 is equal to, we have 2 multiplied by 2 to the power n minus 1. Here it is as our general formula has been substituted. Then, ladies and gentlemen, remember that we want to solve for this n. So we are now applying methodology that we need to use in terms of solving for exponential equations. So we have 16,384 this side. We have 2 times 2 to the power n minus 1. So we have to divide both sides by 2 because we want to get rid of this 2 so that we are left with this, right? So we divide both sides by 2. And when we do so, this 2 cancels this 2. And then here we are left with 8,192, which comes from 16,384 divided by 2, right? And then on this other hand, we have now left with 2 to the power n minus 1. So 8,192. Ladies and gentlemen, some people don't know how to find factors, right? On your calculator, you don't have to stress yourself. Please, my calculator is very old. So it no longer has indications on the buttons. So please excuse me, but I know it by head. Right, so to find the fact, we have 8,192 is equal to, then we press shift, then we press this button, we have fact. So it already gives us 2 to the power 13. I hope you guys saw that. I'm going to repeat it again. You say 8,192, and then you press is equal sign, and then you press shift, and then you press this button, fact. Then it gives you this good looking number with its exponent. It gives you a base 2 with an exponent of 13. So that is why here you will be seeing us having 2 to the power 13 that is equal to 2 to the power n minus 1. Why? Because we want to get rid of these bases so that we are left with only exponents and solve. So here we are. These 2 cancel the 2 because they are the same bases. Remember, this happens only when the bases are the same. So we have the index there. We have 13 that is equal to n minus 1. So we take this minus 1, we transpose it to the other hand, then 13 plus 1, remember when you transpose, sign changes. Then we are left with n. So what is 13 plus 1? It's 14. Then 14 is equal to what? N. So therefore it means n is equal to 14, ladies and gentlemen. So that's how we find, or that's how we solve for that exponent n. Thank you. Thank you. Thank you. Right, now let us look at quadratic sequence without wasting any more time. Let us now very fast look at quadratic sequence, ladies and gentlemen. So under quadratic sequence, we say now quadratic sequence is a sequence of numbers in which the second difference between any 2 consecutive terms is constant. Let us now look at that. Now, the general formula for the nth term of the quadratic sequence is Tn, that is equal to an squared plus bn plus c. Right? Why do you remember that? You remember that, ladies and gentlemen, from grade 11, right? From grade 11, you remember that. Where we had what? Where we had something that looked like this. X is equal to what? Is equal to ax squared plus or minus bx plus or minus c. Right? You remember this from using a quadratic formula. Right? So that is why hence this is called a quadratic sequence. Nonetheless, let us look at this, ladies and gentlemen. Let's say now we have 4 terms. Here we are. We have T1, T2, T3, T4. Now, from this sequence, this is a sequence, ladies and gentlemen. Now, from this sequence, we want to find the second difference. Now, to find the second difference, I know this thing will confuse many people, but it's very simple actually. Let's look at this. we have a plus b plus c. Then we have 4a plus 2b plus c. Then we have 9a plus 3b plus c. Then we have 16a plus 4b plus c. Now, in order for us to find a second difference, we need to find the first difference. Then we'll find the second difference from the first difference. The first difference will not be constant, but we'll get the consistency from the second difference. Right. Now, let us look at this. Now we have a plus b plus c, right? Now to get to there, to find the difference between the two, ladies and gentlemen, what is it that we do? We say remember, from arithmetic sequence, we say Tn is equal to D. We say D is equal to T2 minus T1. D is equal to T3 minus T2. You remember this? This is from arithmetic sequence. Right. Now, we are going to now subtract this from this. So meaning we are going to say 4a, right? 4a plus 2b plus c, then minus a plus b plus c. Something like this, but you're not going to focus on this anyway. So, look at this. What is 4a minus a? Remember, we have an invisible one there. So, we are going to have what? Something like 4 minus this one. It will be what? 3. Because we're having same variables, we're able to minus, right? That variable will go there. Then, ladies and gentlemen, we have 2b, we have b, right? So, 2b minus b, remember, we have an invisible one there. So, 2 minus this one is the same as 1. Hence, we are having b. C minus c, 0. So, here we have 3a plus b as the difference between a plus b plus c and 4a plus 2b plus c. Now, we get to this one. We have 9a plus 3b plus c. We are going to subtract this with this. Now, 9a minus 4a is 5a. 3b minus 2b is b. C minus c, 0. Hence, we're having 5a plus b. Now we get to this one. 16a plus 4b plus c. We're going to subtract 9a plus 3b plus c. Now, 16a plus 9a is 7a. 16a minus 9a is 7a. Then 4b minus 3b is b. You're left with only one, right? C minus c is nothing. Then we come again, ladies and gentlemen. We come to this one and this one. This is the first difference. Remember, in quadratic sequence, we have two differences. The first difference, which does not have any consistency. The second difference, which has consistency. Now, 5a minus 3a. Remember, 5 minus 3 is 2. Then because of we are having the same variables, we're going to have a variable a there. Remember, we're only able to subtract and we are only able to add commutatively if our numbers are having, if we have coefficients that having same variables. Right, so then we're having 2a right there. Then 7a plus b minus 5a plus b, 7a minus 5b, we are having 2b. b minus b is 0. So 7a plus 5a, 7a minus 5a, we are having 2a. So b minus b is 0. So now we have the second difference, which is 2a. That's basically about the geometric sequence. If you can master this, you can master pretty much questions that has to do with quadratic sequence. Nonetheless, we'll continue with trying to find questions from different question papers. Thank you, thank you, thank you.